In this video, we introduce matrix inverses, which sort of allow us to divide matrices by rewriting the division as multiplication. So let's select A and B be square matrices of the same dimension. Then we can multiply A, B, or BA. But can we divide one matrix by another? A divided by B. Well, no, not exactly. But we may be able to do something similar. Think of real numbers. If we want to divide one real number by another, say 2 divided by 7, we can rewrite this multiplication, this as multiplication. 2 multiplied by 1/7. Division is the same as multiplication by a multiplicative inverse. Remember that two numbers are multiplicative inverses if their product is 1. And we do have multiplication for matrices. And we have an identity matrix which acts like 1. So we can define the inverse of a square matrix A. It's the matrix denoted like this, such that their products are the identity matrix. Remember that matrix multiplication is not commutative, so these would normally be different, but here they're both the identity matrix. Now, there's a catch. Every non-zero real number has a multiplicative inverse, but not every non-zero square matrix has such an inverse. For example, take the matrix with a 1 in the upper left corner and 0s everywhere else. If we multiply this by another matrix, it leaves the upper row alone, but turns the bottom row to 0. So since we don't have a 1 here, this can't be the identity. Remember that the identity matrix has 1s down the diagonal. Now, having said that, the matrices we're going to work with are mostly going to have inverses, for technical reasons having to do with linear independence of solutions. We do not learn to find inverses by hand in this class. On a practical level, you couldn't do it for large matrices in any case. Let's find the inverse of 1, 7, 2, 4 on our calculator. We'll simply enter the matrix, overriding this old matrix that was already there. And then we'll simply press this button with the negative first power on it and get our inverse as you see. In this video, we have introduced matrix inverses. Although we will make use of them, it's worth mentioning here that finding matrix inverses is a grave problem. It's both slow and numerically unstable, and not at all recommended if you can avoid it. We discuss this further in linear algebra.